For the function f of x equals x to the fourth, what transformations must be applied to f of x to create g of x equals negative 3 x to the fourth? Graph both functions. Now notice the negative 3 is not grouped with the x, and it could also be written this way, and it would mean the exact same thing. Okay, so let's look for transformations. It doesn't seem to be any translation. There's a negative 3. The negative outside in front of the x means you're doing a vertical reflection, or in other words, an x-axis reflection. And the 3 means you're doing a vertical stretch. I'll put by 3 here. So it's by a factor of 3, but I just write by 3. It's a little simpler to write. Okay, so that's what I think. I think we have the negative sign in front, and that's an x-axis or vertical reflection. And then we have the 3, which is a vertical stretch by 3. So now let's graph both of these on the calculator and see what it looks like. Okay, so I'm going to clear out my old functions. And then my first one is f of x equals x to the fourth, so I'm going to do x to the fourth power just like that. And the next one is negative 3, and then I'm going to put the x in parentheses. You really don't have to, because this calculator does no order of operations. Okay, so let's take a look. We have the first function is this x to the fourth. Second function is the g of x, so it'll graph the f of x first and the g of x second. Okay, there's f of x. There's g of x. Okay, there is a reflection over the x-axis, and there is a stretch here. I know it's a stretch because this graph at the bottom here, the g of x, is narrower. And if you go to the table, let's see if that provides more detail. Okay, let's compare the inputs and outputs. So the inputs here right around 0, 1, negative 1, those are the easiest values to see. Notice that for f of x, x to the fourth, an output of 1. But then for g of x, you have a negative 3. And for negative 2, it went from 16 to negative 48. So you're really multiplying all these outputs by negative 3. So that's why it's stretched vertically by 3. The g of x values are 3 times further away from the x-axis than the f of x values. And they're negative because of the reflection. Okay, so looking at the graph, I could tell there's a stretch. Using the table, I can see it's a 3 times stretch because the outputs for the g of x are 3 times that of the f of x. So I can definitely conclude that these transformations are correct. X-axis reflection, vertical stretch by 3.